Hi, welcome to yet another blog in the EKS Anywhere saga series. And since we are toying around with the idea of bare metal clusters with EKS Anywhere, it's imperative to note that bare metal clusters can work with Ubuntu-based installations or Red Hat-based installations or Bottle Rocket. In my previous blog, I have demonstrated how to create the OS images for the bare metal nodes based on Ubuntu distribution. And this time around, in this blog and in this video, we will look to observe the creation of Red Hat 9.2 OS images for the bare metal nodes. I have already documented most of the steps on my Medium blog, and this video will simply supplement the results and the outcomes for the same. Now, as a preparatory step, obviously, to create the images, you always need a machine, a bare metal node itself with either Ubuntu or Red Hat, does not matter. But you load the image builder utility from AWS and then run that image builder utility to create the OS images that will be used in the nodes. Now, like I said, it does not matter whether you're using a Ubuntu-based image builder server or a Red Hat-based Red Hat-based server actually for the image builder. All you do is run the utility to create the target images, depending upon whether you want to create a Ubuntu or a Red Hat. So let's start. In my case, I have a bare metal server, which is actually a prerequisite with virtualization enabled on that and certain packages installed. But most importantly, some of the steps that are required for the SSH configuration on this particular Ubuntu node, which will be serving as the image builder, are documented here. I have already performed these steps on my server, so we can skip that. The next would be obviously to download the image builder utility itself on the host from where you will be creating the images. Once the image builder utility is installed, we will be creating an image builder user and installing QEMU and other packages which are required to create the OS image. Okay, so all these steps I have already performed on my Ubuntu host. The next would be basically to log in into your Red Hat account, and you have to download the ISO file for 9.2 and download the ISO file locally so that you don't have to reach it to the internet again and again. So I've already done that as well. Okay, I've just given you, this is a simple step here. Once you have the file, basically, I place it in my directory as the ISO file with the name being RHEL 9.2 x86-64 ISO. The next step would be obviously to supply or create a file called as bare metal-rhel.json, in which you will provide for the ISO URL itself. So in this case, since the ISO file has been placed locally, I'm supplying the local directory path, plus the checksum, which can be obtained from the developer portal of Red Hat. So the checksum. And I have also to supply my RHEL username and password. Okay, it will create a temporary subscription, but that's okay. Once this is done, all I need to do is to run this particular image builder build OS Red Hat, and I'll explain this particular command to you while I'm running the utility itself. Okay, so let's go ahead and see my system. So this is the Ubuntu host. Let me increase the font size. Make it 14. Okay, so this is the Ubuntu host on which my image builder utility, the bare metal.json, and other packages which are actually required are already kind of installed, right? Let's see the commands that I have to run to create the OS image. Now, I will clear up some of the previous, temp folders which were created as a part of the previous. So this is important. You have to remove the previous instances of any build tooling directories which were created through the image builder utility. There is a sort of a caveat which I won't go into extra details right now, but you will have to run an export statement with Ansible, SCP, extrargs, this particular value. I've already documented that in the blog. The next step would be to obviously run the image builder build. OS is Red Hat. The OS version is 9. The hypervisor is bare metal. The release channel obviously is 1.29. If you want a 1.28, 1.30, you've got to specify the release channel accordingly. The bare metal.json, which has the specifics in terms of the ISO URL, the checksum, my RHEL username and password and whatnot. But the most important part, which I figured that it's not adequately documented well on the EKS Anywhere website, is that we need to supplement the -- firmware EFI parameter, because by default, when you create a Ubuntu-based OS image for the bare metal nodes, it is an EFI supported image actually. But when you are creating a Red Hat based image, if you don't supply this particular parameter, it becomes a BIOS image actually. Now, apparently what I've found is that when you create the cluster, the 9.2 or the 9.x RHEL needs UEFI support in the BIOS configurations, which means the target image also that needs to be created has to have the UEFI support actually. So this is a very important parameter that we will have to pass along. Otherwise, your image will not have enough parity to be run in the cluster. So let's take this particular set of commands. Okay. And I will pass it here. And you will find a certain, along the journey of this particular OS creation, there will be a point at which, there'll be a kind of a hung state, let's say. Processing takes a lot of time actually. So don't worry and don't fret about it. We'll see. So as you can see that the process has already started. And let's see the point at which I wanted to highlight that you don't need to panic. Okay, so right now it's doing all the necessary things of downloading the build tooling and everything else, installing Packer. Okay. Okay, cool. So all this will go on and continue to a point where it'll create a virtual machine based on QEMU, okay, which will be used to create a virtual machine of sorts for the ISO, for the image build actually. So you can see that, the QEMU has been ignited here. Say that. Okay, so while this happens, let me just pause the video and come back once it moves a little ahead actually. So as you can see that, it basically starts a virtual machine on this particular host. There's virtualization enabled and it randomly selects a port. The VM is started and waiting for the boot of the VM and things like that. Now, at this point, I've observed that this can take anywhere between 3 to 5 minutes waiting for SSH to be available. I'm pretty sure that there's a lot of background tasks that are happening. Some of my colleagues who have tried to do that, they figure out after 3 minutes, that this is not working. So they break the sequence. So don't do that. Let the process continue. Just have some patience, right? Let me pause this particular video and we'll resume when the steps go ahead, actually. So we can see that the message, we moved along, after roughly 5 minutes or so, the provisioning with Ansible has started, and this took about 5 minutes. So that's the reason, I said that people, sometimes fret out. And so, yeah, I mean, the process has started. This will take another 10 to 15 minutes, depending upon multiple things, right? So let it continue. I'll resume once the image is fully created, actually. So we can see that roughly after about 21 odd minutes, the build is completed, and the artifact has been located with the name as RHEL-9-Q V1 29.8, right? Yeah, 29.8 GZ. Okay, so I think that's about it. What we can do now is, oh yeah, so the artifact name is this one, 129 GZ. So what we can do now is simply take this particular zipped image and place it on a web server where when the cluster boots up, the Tinkerbell workflows would make sure that the OS images are downloaded to the respective nodes when the cluster creation process happens, right? Yep. More than that, I think personally, I like to rename this particular artifact to -UEFI, just to kind of make sure that when we load the images, we know that what is the image support there. Other than that, I hope this was an insightful video. Thanks a lot. Cheers. Bye. Thank you.